Okay, well, this is my presentation. So anyway, all of you know me. It's a very select group we're talking to today, the beta testing for software around the globe. But anyway, my name is Fede. I'm from Argentina, but I'm working right now and living in the Netherlands. And I've been doing mostly, full stack development all around JavaScript. And well, over the last year and a half, I've been developing my own front-end framework. So I know I wrote my own front-end framework. I'm crazy, indeed. I don't really understand why, and I should probably recourse to therapy to know the real reason. But for whatever reason, I decided to make my own front-end framework. So basically, the goal of this framework is to allow me to create web applications and just solve most of the problems that you encounter with this. So the thing is, I don't want to talk about my framework in a traditional way today, like saying, okay, this is my framework, this is how cool it is, and this is how you create a hello world. Or also, I didn't want to say, hey, this is my framework that I'm doing, and this is how it compares to the big competitors like Angular or React or whatever it is. So I just wanted to do something different, and this is because of Burnout.js, which probably is also a library because everything has JS now. At the end, there's a lot of thriving. The JavaScript ecosystem is really thriving nowadays, in I don't know, the past 3-4 years. But this has also led to a lot of burnout for developers across the board, both burnout for people who work with JavaScript and feel that they have to be constantly learning what's the latest and greatest framework or how do they compare or whatever. You have all these flux of ideas and especially frameworks and categories, and that's it can really burn you out. And even if you're sitting outside of that, you might be sick of hearing about that. So instead, I just wanted to take a couple of steps back and focus on patterns instead. I mean, during this process of creating and implementing this framework and then creating a couple of real-world applications with it, I found a few patterns that even if I had to lose all my code, but then I just had to build another framework, these are the lessons that I learned. Some of the patterns are about the nature of the problem itself. What's the nature of a web application in general? I mean, what patterns I see happening there over and over. A few others are basically patterns that are emerged as solutions to those problem patterns that I found before. And then there's also going to be a couple of implementation patterns, which are kind of like tricks that I found to make this whole thing work. So basically, I just don't want to focus on the specifics. I just want to talk about the patterns or shapes that actually make things work. And I mean, my framework is open source. You can find it there, and it's not widely used at all. But I did manage to create a couple of real-world applications, some of them actually quite complex. So I know this will scale to a certain extent. So that's why I just said that my experience there is moderate with it. So anyway, without further ado, and also last thing, I will try not to show you much code. I'm lying, actually. There is some code here and there, but overall, I'm really trying to keep it lean. So anyway, if you have any questions, just feel free to let me know. As you go, I'll just try to check the questions or whatever. So let's keep on going. So terrain patterns. By this, I refer to the patterns of what front-end web applications entail. By the way, this I don't know how good you can look at this because of the quality of the video, but this basically comes from the work of an architect called Christopher Alexander. It's actually the sequence of how a certain part of Venice evolved over time. The first picture is about 1400, and then the last one is about 1600. And this architect, Christopher Alexander, he basically created the concept of certain patterns that have certain very positive properties. And from here, indirectly, the movement of software patterns emerged later in the 90s. But this guy, Christopher Alexander, is a real inspiration, and I really recommend that you go and check him out. Actually, this is the most important thing I will give you in this talk. So anyway, patterns, they start with Christopher Alexander, at least for me. So anyway, I don't know if you remember before 2005 that we didn't really have web applications. We just had web pages. And a web page was a very simple thing. You just went with your browser to a certain URL, and then you just got that. And then the server replied to you with some HTML and CSS, which was rendered in your browser, and that was it. So the rendering process was done once, and then you would click on a link, you would request a different page, and then the whole process would happen over and over again. So that was basically building web pages back in 2005. But then something happened. After 2005, something entered the picture here, and then web pages started becoming more like web applications. So from a customer, from the perspective of the user, you could say that basically a web app is something more responsive than a website, something that responds faster and also has some kind of offline capability. The thing that really did the change from web page to web application was AJAX. AJAX basically means that the client, which is your browser, can send a request and get some information from the server without refreshing the page. So let's go back to the classical model. You have a link, and then you get a new page from the server, and you refresh the whole thing. Or if you submit a form, and you click on the submit button, which has effectively the same result. You just refresh the page. With AJAX, and that's what really makes a web page to become a web application, you actually have only first, you load the page, the HTML and CSS, in the bootstrap step. You just basically get some HTML and some scripts. And then when you click on, I put it here as action, in the same place as the link before, it's not that you refresh the page. Rather, you just trigger something. Then the JavaScript here in this page is going to do an AJAX request to the server. And then the server is going to respond with more data. And the JavaScript is going to be updating parts of the HTML and CSS. So this is a totally different proposition. And it was, of course, a very gradual process. But this is basically why it's different to create a web application than a website, and why it explains to me at least the existence of frameworks. For a long time, I actually thought that web frameworks were just because people wanted to write code and do complicated stuff. But over time, I started to understand that all of this, actually makes things more complicated. So anyway, these are a few differences between the web page and a web app that I stole from a previous presentation I gave. So basically, yeah, that a web page only retrieves info or sends it through a page refresh, and a web app doesn't do it. And a web app renders the page multiple times because it updates it, versus the web application versus the web page, which is just rendered once. And so anyway, and it's also interesting to consider that you think, especially if you are full stack or if you mostly tend towards the back end, you say, oh, creating a website, an interface, the design might be hard, but the programming behind it, actually, it's easy. But when you start to think and compare it with other problems that you are solving all the time, it's not trivial because, for example, in a batch program that you are running on a server, you don't really have much state. I mean, you just load a file from the disk usually. Then you start performing computations. You just use the main memory for that. And then when you're done, you probably write something else to a file, and that's it. When you have, for example, a web server route, and this would be the backend part of web development. So you basically get a request, and then on the process of getting that request, you get some data from the client, and then you can take that data, you can interact with a database, and then you reply to that thing, and that's it. But you don't hold state in the middle. The database is in charge of holding that state. However, when you're actually creating a web application that has some state, you actually have to handle that state yourself here, and you need to trigger multiple interactions with its sequences. So actually, creating this is probably somewhat more complicated than just creating web routes that don't really have much state because they just put it in the database. So that's an observation for those of you that maybe think, what's the big deal with all this complexity on the front end? So anyway, if you want to create a web application as opposed to a website, you need JavaScript. So you need JavaScript at a minimum to perform bidirectional AJAX to basically send data to the server and then get the data back to from the server. Then you need to update parts of the view because remember, there's no page refresh. And then you have to handle the navigation on the client because you don't refresh the page. You need to change the URL, or you might use hash-based navigation. So this is basically a single-page application. I'm sorry if some of this might be obvious. it probably is obvious for you. For me, like collecting all these facts took me a long while, and it's only now that I can just speak clearly about them. And anyway, optionally, you can generate the HTML and CSS on the client. This is client-side rendering. And you can also hold the state of the client itself in JavaScript. So anyway, this is just to go back to summarize. This is basically the patterns that you see in the terrain. Like these are the actual problems that you have when you're creating the front end of a web application. So now I'm just going to go with some solution patterns, like patterns that managed to solve the problems that I encountered when I was trying to build web applications. And also, this is from Christopher Alexander. He really studies a lot carpets from the Middle Ages in the Muslim world, and he explains how the patterns are very sophisticated and interlaced. Again, I highly recommend that you take a look at his work. And anyway, my patterns are definitely not in the same category as this. So anyway, I am going to divide the patterns that I found into the solution patterns. I have the static ones, and then I'm going to have the dynamic ones later. So this image is from Raiders of the Lost Ark, and it really represents to me the embodiment of something like stock, stuff, state, just being there. So very static. So the thing about static patterns is that we're not going to be concerned how things change. We're just going to be concerned about what's there in place. So just let me see the questions to see somebody saying something. No, never mind. Thank you, Grupo. Yeah. So HTML and CSS generation, that's the first pattern. Let's just jump into it. So you need to generate HTML and CSS. You could technically do that from the server. I even did it back in the day, but I decided that the client should be able to generate its own HTML and CSS because actually of the second static pattern that we'll cover later. Just for now, bear with me and go with the assumption that we need to generate HTML and CSS on the client. Then we'll see why this is convenient. So normally, the general approach that you have towards this is that you use a markup language because, as you know, HTML is not a programming language. It's actually a markup. So you need to use some sort of thing that looks like HTML, but it's not HTML because it gives you the power to iterate over a collection and then just generate HTML from there or have some kind of conditional. It's a big topic, and I really don't want to get much into it. But essentially, there's ways to do it. The way that I chose to do this, I decided to represent HTML with JSON. JSON is a subset of JavaScript, which is basically objects and arrays in JavaScript land. So it's object literals and arrays, which are number lists and then key lists. You can name them as well. And then I found out, this was a few years ago, that it's actually quite easy to represent HTML with object literals and to generate HTML from object literals. So for now, you might not see the advantage, but at least you can see the direct mapping here. Like this is HTML here on top. And then here on the bottom, you have an array where the first element is a tag, which is a string P. And the second element is the content of the actual tag. So this can generate the HTML above. So we're going to the second example. You can have the same thing if you have a paragraph with a certain class. Then you can basically have an array where the first element is also a P, string P. And then you have an object here, which gives you the class and then the name of the class itself. You can start making this more complicated. You can start nesting tags. And for now, you might be asking, what's the reason for this? We'll just get there. Just give me a minute. But basically, you have a div. And then within the div, you have an array here. And then you can stick in the paragraph there. And you can see that this paragraph has both the attributes and the contents. So the thing about this is that this actually allows you to have some JavaScript code, which has basically unlimited power because it's a programming language. You have the unlimited code, so you're not dealing with some kind of markup construct like a for each or those things that you probably saw in Angular. So it's like a full-fledged programming language. And then you have like a conditional. Here's a ternary, for example. You have a certain condition, and then you can return a tag based on that condition, or you can return nothing. An empty array basically maps to nothing. Or you can set a class conditionally as well, like you see here. Or this is the best. You can iterate. I told you there was going to be no code, and I really lied there. But if you can follow more or less here without really getting too much into the details. So I'm basically generating a table by iterating items, and items is just an array of items. So I can return one of these objects that map to an HTML by iterating each of these items. And this is very powerful because you can basically have the unlimited power of JavaScript. Well, unlimited power. Anyway, you have the power of JavaScript, the power of a programming language, and then just return the HTML. And you can also do this with CSS. I didn't want to waste your time with this, but you can do the same thing with CSS. So you can generate the HTML like this. And so basically, the first static pattern that I see when you're just trying to solve the problem of front-ends, web front-ends, is that you have a function that receives something. We're going to see what soon. And then you just return these object literals that represent HTML, CSS. And there's really not much way around this. If you want to do client-side rendering, you need to generate this HTML, CSS at some point. So you might as well do it within a function. And instead of returning strings of HTML, CSS, it's actually much nicer to return these arrays and objects because there's many things that you don't have to be doing manually, and there's many sources of errors that you can avoid if you have this layer that converts these kinds of literals into HTML and CSS. So let's see if there's any questions so far. Oh, everything's good. So let's move on to the second static pattern, and it's the state is king. The state is everything. And what do I mean by this? So here we can see Thomas Hobbes, which is the main political theorist of the state. And basically here, Thomas Hobbes basically has an object literal in his heart. And this object literal, very simple as it is, it's the state. It's the state of the application. And this is essential because let's go back here. Let's go back to this picture here, the static pattern. See? All these boxes. I mean, yes, you're going to see the HTML and CSS on the page. There's no going around that. But that HTML and CSS is going to be determined, essentially, by the state of the client. The state of the client is basically everything. Is what interactions did the client have with the server? What data did the client fetch from the server? What data is currently being showed in the client itself? So all these things are the state, is whatever goes inside of each of these boxes. So the state is essential. And we're going to make the state king, and we're going to represent all the things that matter for the state of application. We're just going to stick them into this object called the state. So by no frills, I mean, this is a plain object. That's it. So if you combine the two static patterns, the overall pattern is not that complicated. You know, you're going to have a function that takes the state as an argument, and we're just going to return object literals that represent HTML, CSS. So if you see things as unchanging, which they are not, but let's see it statically, that's the overall pattern you have here to generate views, to generate whatever is being shown on a screen in a web browser. You have a function of the state that returns object literals. Of course, you have this layer that converts the literals into the actual HTML, CSS, but that's fine. It's not a problem. So let's go with the dynamic patterns here in this running from the boulder. And the dynamic patterns are two as well. They're quite similar. I just put it in two so it's easier to grasp. But basically, it's all about events. So if before in the two static patterns, we were concerned with things that happened like were immutable, not immutable, just like at one point in time, this is how things change. And the whole thing is based around events, or at least I found it very easy to reason about thinking with events. So the first type of events, well, before we even get into that, I just created my own event system. Since I'm creating my own framework, I might as well reinvent the wheel here as well. But actually, it wasn't that hard at all. And it was quite enlightening as to what parts are really essential to make this work. So I created an event system that is quite simple based on the following things. So you have a verb, you have a path, and then you have the argument. So when you fire an event, you just basically fire an event with a verb, with path, and then you can add optional arguments. So very clearly and related to data events, it's as simple as having 3 verbs. You don't need more than 3. I mean, you could have more for convenience, syntactic sugar, whatever. But basically, you can have add, set, and rem, which is short for remove, and then a path. And basically, what you can do with this is you can mutate the state. You can change the state. And also, instead of changing the state directly, you can actually change the state through an event. So this is the main pattern. For example, you have within the state, right? You have users. So I'm just going to set users. I'm going to initialize the users to an array with 2 elements. These are very simple things, of course, because I wanted to keep the slides short. But I'm just setting users to an array with 2 elements, ID1 and ID2. And then, for example, and as you can see, red here is the verb, green is the path. All of these paths are kind of, I want to say trivial, but they are simple because they only have 1 element. I'm just affecting a top-level element of the state, but nevertheless, this is how you would express it. And here, in this second thing, I'm adding another user, which is ID3. And then, in the last one, I am removing the second element, because JavaScript is 0-indexed, as 0-indexed arrays. I'm removing the second element from users. So these events basically can modify the state. And at the same time, they have other good properties. So basically, what they do is they modify the store, and then they fire an event. And why do we fire an event? Because there's going to be some other parts of the page, of the system, that are going to be interested on when certain parts of the store change. So that's why we also fire an event. So this is the data events pattern, the simple dynamic pattern. So far, so good. Let me check if there's any questions. Okay, I hope I'm not losing you. Just feel free to ask me anything. So the complex events pattern is when you have to create operations that are not just about writing something into the state, but rather you need to do something more before you write to the state. After, you might do it conditionally on the state having a certain condition or not. So for example, like imagine you have a system for managing users. So you want to submit a new user, right? So here you have the verb submit. The path would be, well, here's a typo. It should be users, plural. Sorry about that. And then you just submit the actual argument, which is the new user you want to create with the ID 4. Or for example, imagine you want to retrieve all users. So retrieve users. And then you want to add a filter. I mean, we haven't seen this, but you could totally imagine. Actually, I have written code like this. So these events are more sophisticated, and that's why I call them complex, because they optionally read the store. And by store, I mean state. I'm really mixing the terms here. I apologize. It should say state here, but it's the same thing. They are just reading that big object in the center of Thomas Hobbes' heart. And then after they read it, they perform some computation, or they just do an AJAX request to the server. Usually it's AJAX. Then they update the store optionally, depends on if they're bringing data that is interesting or not. And this is perhaps very interesting. They can also trigger other events. So an event handler can trigger another event, directly or indirectly. So basically, if you put all of this together, and I hope this is not too confusing, a view is essentially a function that takes a path. This path basically tells it what part of the state am I interested in taking a look at, like from which part do I depend? Because you can depend from the whole thing, or you can just depend from a small area. For example, if you're creating a view to list users, you would only depend here from users. You wouldn't depend from, I don't know, permissions. You would depend only on the users. Then you have a bunch of complex events that you can put associated to the view. So for example, if you're managing users, then the event to submit a user or retrieve users are going to be listed here. The advantage is that if you tie those complex events to a certain view, you don't have to worry about the life cycle of the event. So whenever this view is not live on the system, then the event doesn't exist. And when the view is drawn, the event is automatically just created, so it's there. So the life cycles are tied to each other. And then you have the function, the actual function that receives the state. In this case, it could be users, for example. And then we're going to return the object literals. For now, just see this. So this is not that different from the previous one. This is the dynamic version of what we saw before, which is this function that returns you this object literal with stringified event, well, with stringified event handlers. Because here's the deal. The user is only going to be able to see HTML and CSS. So you need to find a way to tie the HTML and CSS to triggering some events. So you can basically stick it into onClick or on whatever triggers in the DOM, and then you're just going to generate and touch this whole event system. So this is when you put all 4 patterns together. So that's pretty much it for that's it for the solution patterns. Let's see if there's any questions. Well, let's keep on going with the implementation patterns. I will try to keep it short. Yep. So anyway, there's more than one. I don't know if you ever played around with any front-end library, or you even saw how they're implemented. But when you actually start to think about this problem, is you might have a very fancy and nice event system. You might have a state. You might have this layer that prevents you from just stringifying HTML things to each other. So all is good and dandy. But at some point, you need to change parts of the HTML and CSS that is on the page. So there's, well, the obvious approach would be to say, hey, I don't know, I have a div, and I need to change the whole content of this div. So I'm just going to recalculate this whole div, and then whatever comes out from here, I'm just going to stick it into the inner HTML of that div. So whatever was before is gone, and I just put new HTML there. So that's not very efficient if you're, for example, changing a large view just with a small change. And also you can lose a lot of state. Like, for example, if you have dropdowns or stuff like that, it's very hard or almost impossible to store that state. So it's much easier to, instead of just throwing an atomic bomb inside that div, you can actually do something like diffing the div. So that's the approach I took. And why do I call this flatten instead of diff? Because I'll just explain you in a minute. So basically, the folks that actually did React had this problem because essentially when you're trying to create a diff of a piece of HTML, you're basically diffing two trees because HTML is a nested structure. You can represent HTML with tree. So right now, the state of computer science, and I don't know if this is going to improve much or not because nobody has established the lower bounds, but basically the best algorithms for creating a diff of a tree are cubic, which means that they get very slow very quickly. So essentially, you cannot really go with a decent, like a direct approach. You cannot just say, okay, I'm just going to create the diff of the old HTML and the new HTML and apply those changes. So I came up with a very hacky solution or pattern that actually seems to work, which is I flatten the tree into an array of strings, and I actually diff them with the Myers algorithm. And I don't know if you ever heard of this, but this is the same algorithm that is used, for example, by Git to see the diff between two files that you are basically committing. When you have committing a new file and you want to see the diff with the old file, use the Myers algorithm. So basically, the Myers algorithm only works with strings. I mean, it works with files. So I basically flattened these tree structures that I created with the object literals, and then just I diff them. And if they really take a long time in doing the diff, I basically give up after so many milliseconds. Right now, I hard-coded it at 200 milliseconds. And this will happen a lot if you are comparing two HTML pieces that are very different. But when they are actually not that different, this works. The diff is quick, and then I can apply the diff to the DOM, basically to HTML and CSS. So in the end, this very hacky solution ended up working. So it's an interesting pattern to see that sometimes if you don't go with the correct approach, it's fine. It might still work. I mean, it was a total bet, but empirically it paid off. So I really don't want to get into much detail here, but also when you're redrawing views, there's a few tricky things that you need to take care of. One is that you don't want to redraw, like you have views within views, and that's why you have this like this door that never ceases to be open, because you have views and inside the view you have another view. And that's actually quite common and quite useful. So you need to apply priorities, lower priorities to the views that are inside the other ones, in case that both the outer and the inner view want to be redrawn at the same time. And then I'm just going to explain one more thing. I'm just going to leave the last one because it's pretty arcane. So basically, I just basically made all the basic verbs for modifying the store to trigger this change verb. And this change verb is essentially the one in charge of redrawing my views. So essentially, I just put a listener that whenever something is added, set, or removed, change is fired. And change basically triggers the view redrawing mechanism. So that's essentially the implementations patterns I just wanted to cover with you. And I'm just going to leave this for some other time. This is my framework. You can take a look whenever you want. Feel free to make any questions. And yeah, the name is Gatop. It's probably the only framework that guarantees that you're going to go to the B. So anyway, that's it. Any questions?
I don't think there are any. The only one was about the author of the patterns book. I already replied, so I think that's it.
Fantastic.
Thank you, Mono. Thank you, Mono. Thank you, everybody, for being with us during this beta testing. Every feedback is welcome.